When we think of ancient engineering along the Nile, the massive monuments of Egypt immediately come to mind. But travel further south, up the river, and you'll find the footprint of an equally formidable yet widely overlooked civilization, ancient Nubia. While the lower Nile offered wide, gentle floodplains that practically invited agriculture, the Nubian environment was remarkably hostile. As you can see here, the transition from the life-giving riverbank to the desolation of the Saharan sands is abrupt, leaving a razor-thin margin for survival. To make matters more difficult, the river itself actively fought them. This stretch, known as the Middle Nile, is choked by violent rocky rapids called cataracts. These jagged granite outcroppings shattered the smooth flow of the water, making standard river navigation and passive irrigation impossible. The Nubians faced a brutal trifecta. They had to survive a hyper-arid climate, navigate severe geological choke points that blocked trade, and extract water from a river that sat trapped beneath incredibly steep, rocky banks. Standard agricultural techniques failed in this terrain. To thrive, they had to invent a highly specific, localized science to extract resources from an unyielding landscape. The sheer difficulty of the Middle Nile acted as an evolutionary pressure cooker. It forced Nubian builders to become some of the most capable and precise environmental adapters of antiquity. The most immediate problem was food. The narrow strips of soil capable of growing crops sat at an elevation far above the river's waterline during the long, dry seasons. Gravity was keeping the water away from the dirt. Their first major intervention was the construction of hafirs, massive engineered reservoirs dug deep into the earth. These basins were designed to capture and store the heavy, highly erratic rainfall that briefly washed over the plains during the wet season. By holding millions of liters of water securely through the dry months, these reservoirs broke the tether to the riverbank. Entire urban centers could be built miles inland, effectively expanding the borders of their civilization directly into the desert. But the hafirs relied on seasonal rain. To tap into the constant, reliable flow of the Nile itself, they needed to overcome those steep riverbanks. The solution was the rapid adoption and deployment of the sakia, an animal-driven mechanical water wheel. A harnessed animal walks in a continuous circle, driving the large horizontal wooden wheel you see here. This central pivot acts as a mechanical bridge. Its interlocking horizontal teeth connect to a vertical wheel, forcing water against gravity to feed the fields above. By combining the inland water storage of the hafirs with the mechanical lifting power of the sakia, Nubian engineers secured massive, predictable crop yields. This agricultural surplus became the economic engine that funded a monumental empire. With their food supply stabilized, the labor force was freed up to focus on infrastructure. They applied the same geometric precision they used to manage water to the mastery of stone. They constructed civic and religious centers using heavy monolithic block masonry. The structural engineering of these temples relied on dense load-bearing walls, specifically designed to withstand the relentless abrasion of wind and sand that characterizes the Saharan environment over centuries. These stone complexes weren't built in isolation. The urban planning heavily integrated them with the artificial water networks. The grandest temples and palaces were intentionally sited near the massive hafirs, merging civic authority directly with the control of water. The most distinct architectural footprint they left behind is found at Merowe, in the form of these sharp, steep-angled pyramids. Looking at this geometric breakdown, we see the physical constraints they solved. A wide-base Egyptian pyramid requires massive level bedrock. By increasing the slope's angle, Nubian engineers achieved towering height while minimizing the footprint, maximizing the limited flat ground. Every mathematical angle and block placement reflects a calculated response to the unique constraints of the Nubian plateau. These imposing figures represent the Kushite kings, who translated agricultural surplus into a centralized state. With a steady grain supply secured by the sakia, they could sustain the large labor forces and professional armies required to control the Middle Nile for centuries. This geopolitical power grew directly from the infrastructure. A reliable caloric baseline allowed the Nubians to project force across the cataracts, turning a hostile river into a fortified trade corridor. They looked at a landscape of choked rapids, barren rock, and arid sand, and engineered it into a thriving, wealthy hub that connected Central Africa to the Mediterranean world. They mastered the art of forcing water up against the pull of gravity and stacking heavy stone to defy the erosion of the desert. Ancient Nubia demonstrates that engineering greatness is a measure of adaptation, the precision with which a society aligns its technology to the specific demands of the world it inherits.